A center pivot irrigation system provides water to a sector-shaped field as shown in the figure. Find the area of the field if theta equals 40 degrees and r is equal to 152 yards. So I don't like this example, how they say find the area of the field. To me, I think it's more intuitive to think about what's the coverage area of the sprinkler system. You know, if you think about a sprinkler comes out of the ground, and it's like, if you look at this from a top view, the sprinkler like pivots back and forth a certain angle. And so you can think about, based on that angle and how far it's spraying, you know, what's the coverage area of the sprinkler? Because it's gonna spray that with the same power, the same distance ahead, right? So it's gonna make like this a sector of coverage area. So what's the coverage area of this sprinkler? If it's pivoting back and forth 40 degrees and it's spraying out straight ahead of the nozzle 152 yards. Okay, well, we know that we can calculate the area of a sector. The formula is really simple if we use the angle in radian measure. It's not so bad if you use degrees, but it's definitely simpler with radians. So with radians, the area of a sector is, so you start with pi r squared for if you're using any angle, but then you multiply that by the fraction of a full rotation, because this is a full circle. So the fraction of a full rotation of the angle of whatever the angle is. So here we have theta in radians. So a full rotation in radians would be 2 pi. If this was degrees, you'd put 360. If it was any other angle, you'd put whatever. Okay, but what happens is in degrees, you're done, if this is in degrees. But with radians, these pi's cancel. And so, okay, this area becomes 1/2 theta r squared. But again, theta isn't radians. So the r is going to be 152 yards. You got to note what the units are. And the theta is going to be, so we've got 50 degrees times, we need to convert this to radians. So there's 180 degrees, the degrees cancel, for every pi radians. So this is 5 pi over 18 radians. So the area, the coverage area is 1/2 times 5 pi over 18, that's unitless, and then 152, that's yards, but squared, so this is going to be in square yards. So 5 times pi over 18 divided by 2, and then times 152 squared. Okay, I can get that as a decimal. So 10,081 square yards. Now, square yards, I'm not sure how intuitive that is, but we could use, you know, usually Google has a good database of conversion factors. So how many acres is in a square yard? With the Google database, you can type in, you know, as long as you have units of square anything, you could type in square light years, right? Light years is a unit of length. So a square light year, that's an area. You could see how many acres is that. Okay, but we've got square yards, so how many, so a square yard to acres. Okay, so let's go the other way. Let's say, well, okay, we've got 1 acre is 4,840 square yards. So you have 4,840 square yards for every 1 acre. Square yards cancel, and now we've got the coverage area in acres. So 10,081 divided by 4,840. So about 2.1 acres. is the coverage area of the sprinkler. Oh, and actually this is 40 degrees. I put 50 for some reason, so if I correct this, 40, 18 divided by 2 is 9. So 2 pi over 9. 2 pi over 9. So the 2's cancel, so you just have pi over 9. Times 152 squared. 8,065 square yards. Okay, divide that by, so about 1.7 acres. Okay, suppose that in exercise 57, that's the question. This question, the angle is halved and the radius length is doubled. How does the new area compare to the original area? Does this result hold in general for any values of theta and r? So that's interesting. What happens if you double the radius, but you half the pivot angle? Okay, and does this result hold for any general values of theta and r? Well, let's just start with this part of the question. So, okay, we've got the area of a sector is 1/2, and what we're going to do is this. We're going to say area 1 is 1/2 theta 1 r1 squared, and then area 2 is 1/2 theta 2 r2 squared. Okay, so now if we divide, let's do, well, we don't know which one's going to be bigger. Okay, let's just do the A1 is the what we started with, the first question. So if we do A1 divided by A2, the 1/2s cancel, and we've got theta 1 r1 squared divided by theta 2 r2 squared. Okay, now with properties of exponents, we know that we can write this r1 squared over r2 squared as r1 over r2 squared. Okay, so if this is theta 1 here, like this is theta 1 and r1, then we're halving the angle. So we're going from 40 degrees to 20 degrees. So that means that if this was 40, and now we've halved the angle, this is 20, so this becomes 2, right? And then here we're doubling the radius. So this is going to, the R2 is going to be twice R1, so this is going to be 1/2 squared. Okay, so we've got 2 times 1/4, so 1/2. Okay, but what does this mean, 1/2? Well, it's A1 divided by A2 is 1/2. What was A1? The original question was A1. This means that if you, by halving the angle and doubling the radius, you doubled the amount of coverage area. So I don't know how descriptive this is, but if we cross multiply, we've got A2 is equal to 2A1. So there you go. By doing what they said here, we've doubled the coverage area. We have twice the coverage area of the original coverage area. So that means that by doing this, the coverage area would be this times 2, 1.7 acres times 2. So that's like 3.4 acres. Now, how could we have used our intuition to get a sense for that the area was going to be increased, the coverage area, before we even did any calculations? Well, because if you look at the formula for the area of the sector, it's more dependent, more strongly dependent on the radius. The radius is squared. So if you change the radius a little bit, we change both by the same amount. Like we doubled the radius, which we know increases the area, but then we halved the angle, which we know decreases the area. So we weren't sure what was going to happen to the new area. Well, but we changed them by the same amount. We changed them both parameters by a factor of 2. However, the radius is more strongly dependent, or the area is more strongly dependent on the radius. The radius is squared. So by doubling the radius, increase the area by a factor of 4. By halving the angle, we decrease the area by a factor of 2. So the net increases, you increase the area by a factor of 2.